Welcome. In this video I'm going to show you how you can perform a Power Divergence test using Microsoft Excel and my stikpetE add-in. If you want to watch a video without my stikpetE add-in, I also have that one available. So you can get my stikpetE add-in by going to my GitHub account, and there you can download stikpetE.xlam. Once you've downloaded it, you can open Excel, go for File, Options, Add-ins, and then click on the Go button. Browse to where you downloaded the file and then install it. After that, my add-in will be available with a lot of additional functions, and in this video I was going to show you how to do the Power Divergence test, either of a goodness of fit or a independence test. This video will focus on how to actually perform the test, not so much if you should be performing this test. There are other options. So I have marital status from the General Social Survey, slightly adjusted for example purposes, and some gender data. This is all data, there were only male and female. And the marital status was married, divorced, never married, separated, and widowed, if I'm not mistaken. Now the add-in gives you access to the TS, short for test, Power Divergence, and then goodness of fit, and test Power Divergence for independence. For the Power Divergence goodness of fit, you need to input the data, of course, but use a vertical range with the data and do not use the entire column. So don't just select the entire column A, really specify from A2 till and then the last one. If you want, you can actually set some expected counts, otherwise it will just assume that each category was expected to have the same count. The lambda setting, you can set this to either Cressie-Read, which is the default, the likelihood ratio, the mod log, the Pearson or Freeman-Tukey, or Neiman. This will then select the specific power divergence that you're after. You can also decide on a continuity correction, either none, Yates, Pearson, or Williams. For the independence version, it's fairly similar, but there's no expected counts. There is the categories range and categories range for both fields. So then you can actually specify which fields to use if you don't want to use all of them. Again, a continuity correction and a lambda. So it's a simple matter of actually just filling out the formula. So for the goodness of fit, I'll simply specify my range and I'm kind of done. It gives me the sample size, the number of categories, the statistic, which is a chi-square value, the degrees of freedom, the p-value, the minimum expected count, the proportion of cells that was below having an expected count less than 5, and a quick description of which version was used. Now in this case my p-value is below 0.05, which is the usual threshold, therefore we would actually say that it's significant, and therefore that in the population most likely the counts would not be equal for all categories. You can actually also specify those categories as mentioned earlier, and here I'm using for example Neiman, and then you get slightly different results in this case, but yeah, same conclusion, still below 0.05. For the test of independence, and you can see if there's an association perhaps between the two variables. You can do the same things, but now I also add the second field and I get all the results. It shows me the number of rows and columns that would be in the cross table. So basically the number of categories in the first and the number of categories in the second. The test statistic, the degrees of freedom, which is the number, actually not sure, I think there's some kind of formula for that one. The p-value, the minimum expected count, the proportion of expected counts less than 5, and the test that was actually being used. Alright, I hope this video was helpful, and thank you for watching.